A single volcano once cooled the entire planet. Another buried entire cities in minutes. And right now, beneath places like Yellowstone, Japan, Indonesia, and Italy, massive reservoirs of magma are still waiting. Because volcanoes are not dead mountains. They are pressure bombs hidden beneath Earth's crust. And when that pressure is finally released, the results can reshape landscapes, destroy civilizations, and even change the climate of the planet itself. But here's the terrifying part. Some scientists believe humanity is long overdue for another massive eruption. Tonight, we're diving into the science of volcanoes, how they form, why some explode like nuclear weapons, and what could happen if one of Earth's sleeping giants wakes up again. When we look at mountains, continents, and oceans, it's easy to imagine Earth as stable and unchanging. But beneath our feet, the planet is constantly moving. Earth's outer shell is broken into enormous tectonic plates that slowly drift across the surface. Deep below them, temperatures become so extreme that parts of the mantle begin to melt. This creates magma, molten rock filled with gas and enormous amounts of energy. Because magma is lighter than surrounding rock, it slowly rises upward. Over time, it collects inside underground reservoirs called magma chambers, and eventually, pressure begins to build. Imagine sealing thousands of tons of superheated liquid and gas beneath solid rock. At some point, the pressure becomes too great. The crust cracks open, and a volcano is born. Once magma reaches the surface, it is no longer called magma. Now it becomes lava. Most volcanoes form near the edges of tectonic plates. And the most dangerous place on Earth for volcanic activity is something called the Pacific Ring of Fire. This massive belt surrounds the Pacific Ocean and contains around 75% of Earth's active volcanoes. But why does this happen? One major reason is subduction. This occurs when one tectonic plate sinks beneath another. As the descending plate moves deeper underground, water trapped inside the rocks lowers the melting point of the mantle above it. That creates magma, and eventually volcanoes. Many of history's deadliest eruptions formed this way, but volcanoes can also appear where tectonic plates move apart. In Iceland, for example, the crust is literally being pulled open. Hot mantle material rises upward through the cracks, producing volcanic eruptions. And then there are hotspots, places where giant columns of unusually hot material rise from deep inside Earth's mantle. The Hawaiian Islands were created this way. In fact, the island chain is basically a trail left behind as the Pacific Plate slowly moved over a stationary hotspot for millions of years. Not all volcanoes erupt the same way. Some produce slow rivers of lava. Others explode with enough force to darken skies across the planet. The key difference is magma viscosity, how thick and sticky the magma is. Thin magma allows gas to escape more easily. That usually creates calmer eruptions, like the ones commonly seen in Hawaii. But thick magma behaves differently. Gas becomes trapped underground. Pressure rises slowly, sometimes for centuries, until suddenly the volcano explodes. Scientists often compare this to shaking a bottle of soda. If the gas cannot escape gradually, pressure builds until it violently bursts outward. Some eruptions are so powerful that they create pyroclastic flows, superheated avalanches of ash, gas, and rock moving at hundreds of kilometers per hour. These flows can reach temperatures above 700 degrees Celsius. In Pompeii, many victims died instantly as these lethal clouds swept through the city. Some bodies were preserved exactly where they stood nearly 2,000 years ago. But not all volcanoes look alike. Some are wide and quiet. Others are steep, violent, and terrifying. And some are capable of changing the climate of the entire planet. Scientists classify volcanoes based on their shape, magma type, and eruption style. Shield volcanoes. These are the largest volcanoes on Earth. They get their name because they resemble giant warrior shields lying on the ground. Their lava is extremely fluid, allowing it to spread across huge distances before cooling. Instead of violent explosions, shield volcanoes usually erupt more gently, building broad mountains layer by layer over thousands of years. But they are far from harmless. In 2018, lava flows from Hawaii destroyed hundreds of homes and cut through roads as entire neighborhoods were evacuated. One of the most famous examples is Mauna Loa. If measured from the ocean floor, It is actually taller than Mount Everest. Stratovolcanoes. These are the classic volcanoes most people imagine. Tall, steep, explosive. Stratovolcanoes are built from layers of ash, lava, and volcanic rock. Their magma is thicker and traps gas far more effectively. That pressure can eventually produce catastrophic eruptions. Some of history's deadliest volcanoes belong to this category. Mount Vesuvius, Mount Fuji, Mount St. Helens. These eruptions can launch ash high into the stratosphere, generate deadly pyroclastic flows, and sometimes affect global temperatures. Many of them are located around the Pacific Ring of Fire, the most volcanically active region on Earth. Lava domes. Sometimes magma becomes so thick that it can barely move at all. Instead of flowing away, lava piles up near the vent and forms a dome-shaped mass. At first glance, these domes may appear stable, but they can be extremely dangerous. If part of the dome collapses, pressure can suddenly release and unleash massive pyroclastic flows down the volcano's slopes. Several deadly eruptions in modern history were caused by collapsing lava domes. Cinder cone volcanoes. These are the smallest and most common volcanoes on Earth. They form when molten fragments and volcanic ash blast into the air and fall back around the vent. Over time, this creates a small cone-shaped hill. Most cinder cone volcanoes are short-lived compared to larger volcanic systems, but some can still erupt suddenly and violently. Supervolcanoes. And then there are the supervolcanoes. The most terrifying volcanic systems on Earth may not even look like volcanoes. Supervolcanoes are so massive that after an eruption, the ground above them can collapse and form an enormous crater called a caldera. Their eruptions can be thousands of times more powerful than ordinary volcanic eruptions. If a supervolcano erupted today, global temperatures could fall, agriculture could collapse, and food shortages might spread across the world. One of the most famous examples is Yellowstone in the United States. Scientists constantly monitor it. Fortunately, experts believe the chances of a catastrophic Yellowstone eruption anytime soon are extremely low. Can we predict the next eruption? Scientists still cannot predict the exact moment a volcano will erupt, but volcanoes often give warnings. Before major eruptions, scientists may detect earthquake swarms, rise in gas emissions, ground deformation, and unusual temperature changes. Today, volcanoes are monitored using satellites, seismic sensors, GPS systems, drones, and gas analysis equipment. These technologies have saved countless lives, but volcanoes remain unpredictable. And somewhere beneath Earth's surface right now, pressure may already be building again. Volcanoes remind us that Earth is not a quiet planet. Beneath the ground we walk on, our world is still alive. Every eruption is a glimpse into the violent forces that shape continents, oceans, and life itself. And one day, another giant will wake up,